All right, here we go with iChem lesson 11 on covalent bonds. We're going to learn to write formulas and names for those, and also for acids as well. So first, a little bit of review of ionic bonding for some contrast. Remember, ionic bonding is metals or cations bonding to non-metal ions, which are anions. It involves losing electrons and gaining electrons, so the formation of ions, and then those ions are attracted to each other to form a neutral compound. Our example, our sodium chloride example, the sodium atom loses an electron, its one valence electron in its outer shell, to become a stable positive one ion. Sodium gains that electron, so then it satisfies the octet rule with 8 to become a negative one ion. Then opposites attract. Sodium and chlorine are bonded together by attraction forces, and the overall charge of the compound is neutral. So covalent bonding, on the other hand, is bonding between all non-metal atoms, where they actually, instead of giving up their electrons or gaining electrons, they're sharing their electrons. All nonmetals want more electrons so that they have 8. So they share them to achieve stability. We'll learn to name these compounds, write the formulas for these compounds, and then in this lesson, and then later this week we'll learn to draw and analyze the structures to predict the properties of covalent compounds. So first of all, you need to know 10 important prefixes. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 penta. A lot of these, especially the first 5, should look familiar. I think di, tri, like triangle, tetra, like tetrahedral with 4 sides, penta, like pentagram. You can kind of think back to geometry to refresh your memory here. And then you have hexa, which is 6, hepta, 7, octa, 8, nona, which is 9, and deca, which is 10. You need to memorize these 10 prefixes. So make sure you have them written down. If you're still catching up, pause it, finish writing them down, because you won't be able to name covalent compounds without them. All right, so to write the formulas, you use the prefixes to determine the subscripts for each element. There's no ions, there's no crisscrossing, there's no swap and drop. The prefix goes exactly with the compound it's tied to, or the element that it's tied to. So phosphorus, you'll notice there's no prefix on the first element in the compound. If there's no prefix, it's kind of the same thing as writing mon. So there's 1 phosphorus. And tri means 3 oxygens. So 1 P, 3 O's, P, subscript would be a 1, but we don't write it, O, 3. Simple as that. Let's look at the next one. Dinitrogen, trioxide. Di means 2, so 2 nitrogens. Tri means 3 oxygens. Put it together. N2O3. Notice I'm not swapping. The 2 stays with the N, the 3 stays with the O. The prefixes tell you how many of each element are present in the compound. Another example. Tricarbon, octahydride. Tri means 3 carbons. Octa means 8 hydride, not hydroxide here, notice it's just hydride, is 8 hydrogens. The 3 stays with carbon, the 8 stays with hydrogen, C3H8. Writing the names is just the opposite. We're going to use the subscripts to determine the prefix. The first element is always written out the whole name, and the second element should end in IDE. That means that every single covalent compound should end in IDE. There's no other option here. Okay, So nitrogen has a 2 as a subscript. Oxygen has a 5. So the prefix that goes with 2 is, or the prefix that goes with 5 is pent. The prefix that goes with 2 is nitrogen. So 2 nitrogens, dinitrogen, 5 oxygens, pentoxide. You could write pentaoxide or pentoxide. Either one would be appropriate here. Next example. If there's no subscript on carbon, that's an implied 1. The subscript on fluorine is 4. 4 is tetra. If there's no subscript on the first, I don't need the mon. So it's carbon tetrafluoride. 1 carbon, 4 fluorines. Carbon tetrafluoride. Let's do one more example of covalent. So P2O6. The 6 is hexa. The 2 prefix is di. I have 2 phosphorus, diphosphorus, 6 oxygens, hexaoxide. I'm writing out the prefix with the whole compound in the first one, and then the prefix with ending in IDE for the second one. We have a special type of covalent compounds called acids. Acids are covalent in the sense that they share electrons when bonded together. The hydrogen and chlorine in this example are sharing electrons here, and it's HCl. However, when they're added to water, they dissociate into ions. So in some cases, they share properties with covalent, but when they're in water, they dissociate into ions, and they're like ionic compounds. So, how to recognize an acid from the formula? It starts with an H, as simple as that. Examples of some acids. Notice all of these, the first thing is an H. Sulfuric acid, hydrochloric acid, nitric acid, hydrobromic acid. Let's talk about how you name and write the formulas for these acids. So to do that, you need to recognize that there are 2 types. The first type is binary acids that contain a hydrogen bonded to one other element. There is no oxygen. By the fact that it's one other element, it's a monatomic, not polyatomic ion in solution. Versus the oxy acids contain a hydrogen bonded to a polyatomic ion. In most cases, you can recognize the polyatomic ion by looking for an element and some element and an oxygen. So writing the names for the binary acids first. You say hydro, and then the root name plus ic acid. By root, it's the main part of the name of the other element. So here's an example, HCl. It's hydro, and then the root of chlorine is chlor, and then we add ic acid. The next one, we have H2S, hydro, and then sulfur, root is sulfuric acid. HI, hydro, iodine, hydroiodidic acid. For writing the names of the oxy acids, we have to decide on the ending of the polyatomic ion. If it ends in 8, then we name it root-ic acid. If it ends in ite, we do the root of the name us acid. Notice there's no hydro when we do polyatomic ions. So here we go, HNO3. So look at everything but the H, that's nitrate. So this would be, take off the 8, change it to ic, nitric acid. Everything but the H here is sulfate. This would be then take off the 8 sulfuric acid. Here we have nitrite. Take off the ite, replace it with us, nitrous acid. Here we have sulfite, SO3. Take off the ite, replace it with us, sulfurous acid. You just need to look at the name of the polyatomic ion on the back of your sheet, take off the ending, and replace it with the appropriate ic or us acid. Okay, to write the formulas of these. First, ask yourself, is there a hydro? If yes, hydro, there's no polyatomic. Remember this, yes, hydro, no polyatomic. Or you could say, yes, hydro, no O. So, always a hydrogen ion. And then nitric with a hydro means that it's not polyatomic, it's just nitrogen, N3. Then we're following the same process as ionic compounds, swap and drop, H3N. If we look at our oxy acids, we're looking for the suffix. You can ask yourself, no, look for the hydro. If there's no hydro, say yes, polyatomic, or yes, O. No hydro, yes, O. That means you need to look for the suffix. If it's OUS, OUS, you replace it with ite. If it's IC, you replace it with 8. Here I have chlorous acid. I'm going to replace the us with ite, and I have a chlorite ion. So always, there's my chlorite ion, sorry. I always also have a hydrogen ion when I'm dealing with acid. Acids always have H+. You're just trying to determine the other one. I swap and drop. I got HClO2. I understand that naming acids can be a little bit confusing with this whole ite, us, hydro, no hydro business. We'll create a good flow chart in class tomorrow to help you make the decisions on naming acids. Don't forget to do your Google form.